You all did a wonderful job with this activity. Now, how did you feel about doing this problem? All right, so we're going to go on to talk about what is concrete geometry because everyone's saying, oh my goodness, this is a brand new course. It is nothing that you haven't already been teaching. The only difference is we're going to talk about what it looks like in its concrete form. Let's first look at this quote. Knowing how geometry is associated with different mathematical subjects and concepts and how geometric thinking develops in children is a building block for teaching geometry. What resonates with you from this quote?
Something that sticks out to me is just talking about how geometry is associated with different math subjects. I think a lot of times, like people have always like given geometry a bad rap because they're like, oh, it's just one class and it doesn't relate to anything else. But like, especially now teaching it, I see how it's connected to so many different types of math.
Good, thank you. It is. Anyone else want to respond?
To me, it's saying that it's a building block upon the other the math subjects that we have. Like the other subject sets the foundation for geometry. And when it says a building block, it's like we're gonna keep building on the concepts and knowledge that we already know and use that in geometry.
Very good. Because in every other subject that we teach, we always relate it back to a geometric figure. We're not talking about building a building or a garden or some kind of shape, a triangle, some graph. It all relates back to geometry. Okay, so concrete versus algebraic geometry. So I'm going to give you this first column. Concrete geometry is visualizing and understanding geometric shapes, figures, and their properties in a two-dimensional and a three-dimensional space. Uses diagrams, models, and spatial reasoning to explore concepts like area, volume, angles, and transformation. Studies the properties of triangles, quadrilaterals, circles, and solids, understanding geometric proofs and constructions. Uses tools, rulers, protractors, compasses, and geometric software. What keywords jump out at you in this first column on concrete?
Janelle, should we be seeing your screen?
Yes, you might have to refresh if you don't see it.
Okay.
Some words that stuck out to me were, I think someone put it in the chat, proofs, using diagrams and models, and then also like geometric software.
Okay, good. Those are all ways. And when we talk about proofs, a lot of times in geometry, we're used to having two column proofs. Well, we don't have formal proofs anymore. So these proofs can come in the term of you're basically justifying your reasoning, and that is still a proof. We also have models, exactly. All right. Algebraic, you have studying geometric objects like curves and surfaces defined by polynomial equations and using geometric techniques to analyze their properties. Employs abstract algebraic tools like commutative algebra to study geometric objects, often in a more abstract and general setting. Analyzing the solutions of polynomial equations, studying algebraic varieties, sets of points defined by polynomial equations, and exploring concepts like dimensions, singularities, and intersection theory, and abstract algebra, calculus, and advanced mathematical software. What characteristics or keywords jump out at you when we see this in the algebraic column?
We're analyzing
Great, we're analyzing. What else? Abstract, good, and
abstract. What is algebraic keeps jumping out.
right, algebraic. What else?
Um,
I think geometry you can touch. Algebraically you can, think or feel.
Good. Okay, with algebraic, you're thinking. Geometry, the concrete is more hands-on. We have calculus. We have equations in the chat. Good. Polynomial equation. We were talking about equations. Well, how often in the past did we try to take algebra and relate it to a geometric figure instead of understanding the attributes of that geometric figure and then relating it to a more abstract concept? So we're working in the opposite direction this time. All right, the CRA in geometry. What does CRA mean?
Concrete, representational, abstract.
Good, concrete, representational, abstract. We don't see that a lot, and we don't talk about it a lot in high school and upper level classes. Middle school, maybe elementary, definitely, but somehow it kind of gets lost in the shuffle the higher up the educational rung we go. And it shouldn't be like that exactly. So when we talk about the concrete stage, what would this look like in a classroom? What should concrete stages look like in a geometry classroom? Good. Hands-on models. What else?
Like manipulatives and like I guess like shapes that students are familiar with. So like squares and equilateral triangles is like a very basic thing that they're kind of familiar with.
Okay, good. Well, let's see.
Getting to
Look, you are
build
already there.
model, yeah, physical objects, either patty paper or building it with tiles or color tiles or some kind of
Yes.
physical pieces.
Labs, geomodels, geoboards, drawing pictures, physical objects. We're going to get to drawing the pictures. Cereal boxes, soup cans, yes, manipulative. So the concrete stage uses physical objects like geometric shapes, squares, triangles, circles, rulers, protractors, and compasses to explore geometric concepts. Now, what are some examples of how it would be used in a classroom?
Usually when you do the concrete stage, you're kind of introducing the math to kids before they're actually formalized with it. So it's kind of like giving them an opportunity to play around with it and see if they can figure things out, come up with those kind of like notice and wonder type questions based on what they're playing with their hands.
Yes, well said. So this stage is help students develop a tangible understanding of geometric concepts through hands-on exploration. Students will use these physical objects to explore geometric concepts. Examples of use would be to measure angles and sides of shapes using tools, construct geometric figures using a compass and a straight edge, experiment with transformations, translations, rotations, reflections using physical models. Lines and points would be including to use string, straws, or markers to represent lines and points. All right, representational stage. What would this look like in a classroom?
Is this where you start drawing your pictures?
Yes, this is where you would start drawing your pictures. So you would transition from your concrete manipulatives to drawings, diagrams, and sketches to represent geometric concepts. Graph paper, exactly. Using nets to understand surface area. Okay, good. What else would we need what would it look like? What are some examples of what it would look like in your classroom? What would you see students doing?
They'll be trying to create models to
Good.
represent the concrete.
Good. Solving problems visually, creating models, transformations. All right. So they would be drawing geometric figures, accurately labeling angles and sides, using diagrams to illustrate geometric theorems and proofs, and represent transformations visually on coordinate planes. So we're drawing, we're using diagrams and illustrating, we're representing. So this is what the representational stage is. All right, now as you move out of representational, we move into abstract. So what would the abstract stage look like for students in your classroom?
They'll be trying to put everything together to solve the problem.
Yes. They're going to be combining everything they've learned.
Mhm.
And this is when you introduce your abstract mathematical symbols, formulas, and equations to represent your geometric relationships. Now, what are some examples of how this would look in a classroom? Like, what would students be doing? Using formulas. Good. We have formulas in the chat. Volume equal length times width times height. Exactly. Solving equations. All right. So again, examples of use. You hit it the nail on the head. Using formulas to calculate area, perimeter, volume, and surface area. Writing and solving geometric equations. Learn and apply geometric theorems and postulates. All right, we're going to talk about now GS POFR 2.2. This is the indicator that we're going to explore today. All right, so our standard is to interpret the structure of expressions, equations, and inequalities to analyze and make predictions in different contexts. So this is our overarching standard. The indicator we're exploring is to analyze slopes of lines to determine whether the lines are parallel, perpendicular, or neither. And our indicator insight is to address the occurrence of coincidental lines. Exploration of parallel and perpendicular lines outside of its connection to shapes and transversals is a new concept for students. So before now, students would have been exploring parallel and perpendicular lines using parallel lines and transversals. So now this is going to be outside of that scope. What mathematical process standards are we going to see during this indicator? Or could we possibly see during this indicator? Feel free to put your answers in the chat or jump on. Okay, algebra process standard, equations of lines. What are we have 5 process standards. So what
I was gonna say the connections one.
okay, connections.
Mhm.
To explain ideas using precise and contextually appropriate mathematical language, tools, and models. There is one about structure here. What about structure? Give me one more process standard. What could we relate to this indicator?
Um,
Patterns and structures, analyze and justify. Good. Justification, very good. Okay, some vocabulary that we're going to see with this indicator is slope. We have y-intercept, altitude, perpendicular, parallel, coincidental, and reciprocal. So in teaching vocabulary, there are several ways that it can be taught within a lesson. An example is the use of sentence stems. So one example of a sentence stem is, I know the slope is blank because blank. What are 2 terms that we can use to fill in the blanks for this sentence stem? You can put your answer in the chat or you can unmute and give me an answer, a response. I know the slope is blank because blank. Oh, here we go. Very good. I know the slope is positive because the line goes uphill. Great. The slope is positive because the line is increasing. The slope is positive because it's going up. Excellent. And these are all responses that we can expect to hear from students. All right, what about this sentence, Tim? I can recognize when a pair of lines are blank because blank. All right, we have in the chat, I can recognize when a pair of lines are parallel because they have the same slope. Okay, good. Parallel because they never intersect. Good. Parallel because they have the same slopes. Perpendicular because they form right angles. Very good. So these are all ways that students can learn vocabulary without doing definitions or just a test or an assessment on it. They can actually place them in sentences. All right. How do you analyze? So when we talk about analyzing parallel lines, what do you notice? And we're looking at this from the lens of a student. So you would ask your students, what do you notice about the pair of lines? Are they straight lines? In what direction are the lines moving? So what do you notice about these pair of lines?
Those two lines they appear that they're never going to touch each other
Right.
or
They
intersect.
Okay, they appear that they're never going to touch each other, but we don't know that yet, do we? So that's something we want to explore. But very good. What direction are the lines moving?
Negative.
Down to the right.
They're moving down from left to right. Exactly. Good. Okay. Now, if we ask students to choose two consecutive points on the line, how could you move from one point to the next point without picking up your pencil? Oh, great. It looks like one line is a horizontal shift. Okay. Create a slope triangle. Very good. Rise and run. So when we talk about this, what are students going to recognize? They should recognize that as you're moving positive in one relation, you're moving negative in the other, right? And that the slopes are the same. Exactly. What should else they know? What else should they notice about those 2 points? If they were to measure the distance between those two lines, what would they find?
They're always going to be equal.
They're always going to be equal. Exactly. So now we introduce the equations into this. What would they notice?
When we introduce equations, they will say, hey, this is algebra. We are in geometry class.
Right?
And
What else would they?
they'll see the equations are in standard form.
They see the equations are in standard form and that one is a multiple of the other. Right.
Yes.
Yeah. So by the time they finish pulling all this information in, will they not understand the attributes of parallel lines? They'll also understand the difference about constants, yes, and coefficients. One is a multiple. So yeah, they would have some concrete knowledge of these lines. And does it just have to be with one example? Could you have students create this using Desmos or GeoGebra or using graph paper? This is what we mean by concrete. All right, let's look at another one. How about perpendicular lines? All right, we're looking at these lines right here. What do you notice about this pair of lines? Are they straight lines? What direction are the lines moving?
I noticed a four-way stop.
Okay. And what do you notice about that when you say four-way stop?
They have four right angles.
They have four right angles. Okay, good. All right, we have one is in the chat, we have one is increasing, one is decreasing left to right. Very good. They're going in opposite directions. Good. Lines intersect and it shows 90-degree angles are made. Great. All right. So we have proof that they are intersecting lines. What are we going to find out when we talk about the slope? If we were to look for the slope of these lines using the triangle method or picking two consecutive points on each line, what would you notice about the two segments? Okay, we have opposite reciprocals in the chat. What else would you notice?
This is going to be the legs of your
Opposite
right
direction.
angle triangle.
Yes, we have your two legs of a right angle triangle. Exactly. The rise of one becomes the run of the other. Very good. What happens when we take away the box and now we're looking at the equations? What would students wonder? What would they notice?
Like the coefficients switch places.
The coefficients switch places and what else? Very good. All right, we have in the chat the X and Y values flip. Good. What would they notice about the operation? Good. One is negative and the other is positive. Exactly. One equation has addition and one has subtraction. Good. Now, let me ask you this. You're using this in your classroom and you're instructing your students. Does this not have a low floor but a high ceiling for students?
It does.
So all of your students should be able to leave class understanding what parallel and perpendicular lines are and how they are different. Okay, let's look at coincidental lines. How do you analyze? What do you notice about the pair of lines?
There are overlapping lines.
We don't see two lines, right?
Mm-mm.
What pair?
Yeah,
In
but we
the
see
chat.
it's two different colors.
Right, we know that there should be two different colors. Exactly. So, what direction are these lines?
They're going from
Left,
left to right.
They're going
left
from
up,
left.
right down,
Right.
negative
So
slope.
we negative slope. So by now,
Mhm.
students should understand what a negative slope looks like. There shouldn't be any question about it. It should be understood. They are heading in the same direction. Exactly. So can you see two lines? We already answered no. Why or why not? Why can't we see two lines?
Because it's the same line.
It's the identical. Exactly. Yeah, it would be cool if one was yellow and the other was blue. And that would be nice. All right. So again, if we chose two consecutive points on the line, what we notice, we would notice that they have the same slope, right? What would we notice about the equations? Looking at the equations, what could students deduce?
One is in reduced form and the other one is not.
Very good. One is a reduced form of the other.
Mm-hmm.
They are multiples of each other, exactly. From the coefficients to the constant. All right, so here's an exploration example. I took this example from Accelerate Learning, Math Nation. And like I said, these webinars, we'll try to give you an example from each of the curriculum because we don't know right now which curriculum choice districts are making because we have different districts attending these webinars. So this particular example is one from Math Nation, and it invites students to share the effects that they found. You can listen for terms and descriptions such as rotation, 90 degrees, right angle, counterclockwise, origin, perpendicular lines. And what students would do is they could fill out this a chart where you have the original figure slope of each line and then the image slope and the product. And what they're going to be exploring is what happens if we were to extend these lines. So if we extend line AD and A prime D prime, what do you notice? In the chart, what do we know? They're perpendicular, right? They are perpendicular. So this is an example and an opportunity to challenge students to use their vocabulary. So when they say, oh, the slopes look like they're flipped, that's when we have them use the term reciprocal. And we want to stress to them, make sure they use terms such as opposite reciprocals instead of negative reciprocals. And this is an opportunity for you to explain the difference. And as they explore this concept, they'll figure out that the product, when they multiply, will always be, in this particular case, -1. And so they know that they have reciprocal lines, perpendicular lines, as they explore this concept. Another example is the exploration activity, and this is from Savas Envision. And there's a mistake on this example. Can anyone point it out for me? So if you look in the box, in the comment box where it says the line, good, it should be 1-3 instead of 1-4. It should be 1-3. So this is a reminder, and I took this directly out of the textbook, one of the textbooks. Even when you're going over this with your students, always check what has been published because it may not always that come without mistakes. So in this particular question, a landscape architect is designing her yard, which will have a walkway leading to a shed. And that little brown area at the bottom is the shed. So she wants the edges of her walkway to be perpendicular to the back of the house. Can she continue using her design shown below and add the shed, or will she need to revise the design first? So this is an example, a sample problem that students can explore. You can use the slope of the edges and the house. It may appear from the design that the edges of the walkway are parallel and perpendicular to the back of the house. However, once they use their coordinates to calculate, will they come up with the same response? So then students should be able to calculate and compare or draw. This is one of those representational moments where they can draw the picture, plot it on a graph, or use some dynamic software to determine whether the lines are parallel or perpendicular. And of course, you can add some leading questions like, how does the diagram help you determine if the edges are perpendicular to the back of the house? Why is it important to compare the slopes of the lines? And to add something in for students to explain, to take it a step higher, the architect wants the front of the shed to be parallel to the back of the house. If one corner of the shed is at 0.5, can the other corner be at 3 6 5/10. And explain. This one sample problem encompasses a lot of different strategies for students to explore. All right, are there any questions about what we've talked about today? Okay, well, on the
So what
next
we
slide,
have seen that, well, geometry cannot be separated with your algebra, so we have to embed the geometry and algebra together.
well, they're not completely set, which you're moving to understanding the algebra through the geometry instead of understanding the geometry through the algebra.
Makes sense.
So we want students to explore these concepts, to explore these indicators. And again, this is not a testable subject, so it really gives you the opportunity to have some fun with this class and help students engage. And because using the concrete will help have that low floor but high ceiling opportunity, it'll really give students an opportunity and a chance to be successful, and maybe they won't find math so daunting. And then they can move on to the algebra and the algebra 2 with probability and the discrete and the calculus because they'll have a better foundation, a stronger foundation. So I'm sorry, go ahead. Any other questions? On our next slide, we have a feedback survey for you to fill out, and this will help us give you credit for attending today, which we thank you for taking this opportunity and staying after school to participate in this webinar. Will district unit assessments also be? District unit assessments are up to the district. They won't need a low floor and a high ceiling because if these standards and indicators are taught with the fidelity that they should be, the majority of the students should be performing at a high ceiling. It's up to teachers and educators to have that high expectation for students. And they may not always reach the mark, but the hope is that they will have better growth. And so we have this one last quick activity for you to finish. So like I said, don't run away yet. It's a formal reflection for today, and we ask that you take a moment to complete the survey. This helps us determine what needs were met today and what needs we can touch base with you about at a later date to make sure that we're supporting you the best we can. And of course, we do give you credit hours for attending this afternoon's webinar in person, as long as you were in person. These will be posted on the website later, but
Thank you, ma'am.
thank you. Have a great rest of your week. You get a certificate for attendance. We'll send out those certificates. The website, the State Department website, will have these webinars posted. I can't tell you when because they have to go through IT to add closed captioning.